All right, welcome everybody. Today we're going to talk about lesson number 74. As I mentioned earlier, this chapter 10 is mostly about something called the conics, and today we're going to start talking about the parabola. Here you have listed homework number 74, and if you did print out the notes, this is already typed up at the bottom of the back side, so you already have it there. And then again, you have a link there to the Desmos activity, which we likely just went over together. I will provide you with one of those for each of the different conic sections, so please feel free to visit those websites if you think that the visualization will help you. So here, again, in section 10.2, we're starting our discussion about the conics. So a conic is the intersection of a plane and a double napped cone. There are four basic conics that can result, and they're all shown below. You have to remember that these conics assume that the plane does not pass through the vertex of the cone, in which case you get what's called a degenerate conic. We'll talk about those eventually, but for now, we're going to focus on the big four. So take a look at the first one, which is a circle, which is probably the one that you're the most familiar with. That's what happens if the plane intersects parallel to one of the bases. Then in the second one, you have an ellipse. That's what happens if the plane intersects the two sides, but at an angle. You basically get a stretched out circle, which is called an ellipse. Then you guys are used to parabolas, of course, but today's discussion is talking about parabolas in a very different way. So a parabola results if your plane intersects just one side of the cone diagonally. And in the final example, which is a hyperbola, that's what happens if your plane intersects just one side of each of the two cones, and it results in basically a double parabola, which is called a hyperbola. So basically, each of the next couple lessons will focus on one of these shapes, although the parabola, which we're going to start today, we're going to talk about today and in the next lesson. There are several ways to approach the study of conics, one of which we just saw, which is to consider the intersection of planes and cones. The second way is to look at this equation. Notice that in this equation, you have a whole bunch of squares, x and y. You have some xy terms, purely x, purely y, and then the constant. Depending on the combination of these terms is what would tell you whether you have a hyperbola, a parabola, or a degenerate, or any of the different options. We're basically going to talk about conics in the third way, which is talking about all the points that satisfy a specific geometric property. So this here, again, is probably the conic equation you're the most familiar with. It's the equation of the circle. If you were to make h, k, and r into numbers, which we will, and then you were to do out all the algebra, you're going to get some version of this ax squared equation. So again, we're eventually going to learn how can you simply just look at an equation and be able to identify which of the conics it is. We'll talk more about circles for tomorrow. Right now, we're going to focus on parabolas. So again, back in chapter 2, this was what was considered to be the standard form of a quadratic, ax squared plus bx plus c. Notice that when we did those back in chapter 2, you only ever had quadratics that faced up or down, and you talked about them in terms of their vertex and their axis of symmetry. So we're going to kind of shift the focus a little bit. We're going to have a new definition of a parabola. And that definition is as follows. It's the set of all points x, y in a plane that are equidistant from a fixed line, which is called a directrix. Make sure you know that a directrix is always a line, which it means it either has to be an x equals if it's a vertical line, or it has to be a y equals if it's a horizontal line. And it has to be equidistant from both that line, which is called the directrix, and an actual point, which is called the focus. So again, some new terminology here, focus and directrix. If you're wondering how it relates to the old stuff, the midpoint between the focus and the directrix, that's where you would find the vertex. And the line passing through the focus and the vertex is called the axis of the parabola, or the axis of symmetry. So that just kind of reminds you of where the old vocabulary meets the new vocabulary. And then, of course, we're going to need some new equations. So the two equations up top are the more complicated versions of the parabola, and that's when you have a vertex that is not at the origin. These two formulas down here are a little bit more simple, and these are what you're going to use when the vertex is at the origin. Notice that the difference in the upper equations versus the lower equations is whether or not there's an h and a k. If you take a look at the equations, notice that in the first one, it's the x's that are squared. Notice that in the second one, it's the y's that are squared. Regardless, when you're talking about hk, x is always going to be your h, and y is always going to be your k, no matter which of these two versions you have. So very important that you know that. And then p, okay, make sure you understand that p, which is found here, P is the distance from the focus to the vertex, and it's also the distance from the vertex to the directrix. If you want to see the vertex, the focus, and the directrix a little bit more in action and what happens when you have different values of P, I strongly recommend you go to that Desmos site that I posted, because I think that it's a good way for you to get a very clear visual. So again, some more pictures here. A reminder over at the side that I have in every slide. P is always the distance from the focus to the vertex, and also from the directrix to the vertex. That's kind of the whole point. And then please note that the larger that P is, whether it's positive or negative, that is going to result in the parabola being wider. When we sketch these parabolas, you don't really have to worry too much about the wideness, or the width, sorry. You're really more focused on where the focus, the directrix, and the vertex is. So just kind of something to keep in mind. Notice that in both of these examples, you have the x variable that is being squared. How do you know whether or not the parabola is going to face up or down? Well, if you have the x being squared and you have a positive p, that is how you know that the parabola is going to face up. Whereas if you have the x being squared, but you have a negative p, that is how you know that the parabola is going to be facing down. So for everything we're about to do in the upcoming problems, that's really the first question you should ask yourself. Is this parabola going to face up, down, or left or right? So again, you'll know that it's facing up or down if the x's itself are squared. And then notice once you identify the vertex, the value of p is the distance to the focus and also the distance to the directrix. The whole point is that they have to be the same distance. Here are your two other formulas, and this is what happens if the parabola is going to face left or right. So notice in example C here that because you have the y squared, that's how you know it's facing left or right. The fact that it's a positive p is how you know that it's going to face right. Again, you have a y squared. That's how you know it's going to face left or right. The fact that the p is negative is how you know that it's going to face left. So if we're going to try to put those into action, let's go ahead and take a look here at the first four examples. What I want to determine for now is whether the parabola opens up, down, left, or right. What I also want you to notice is that in these four first problems, the equations are already in the optimal formation. If they are not in the optimal formation, you of course have to do some rearranging. So in number one, take a look at the y squared. The fact that it's a y squared is how we know that it has to either open left or right. Once you look over here and see the negative, that's how you know that this graph is going to face to the left. What it means for the graph to face to the left, it means that somewhere there is a vertex. It means that the graph itself is going to be a parabola that opens to the left. Again, this is the vertex. There's going to be some point in front of it, which is called the focus. And then there's going to be some line behind it, which is called the directrix. So those are really the key pieces that we're going to be graphing in each of the examples. Take a look at number two. So number two, when you see that it's an x squared, you know that this parabola is going to face up or down. Once you take a look over here and see that 10 is positive, that's how you know that this graph is going to face up. Taking a look here at example 3, notice these are a little bit harder because h and k are no longer 0. That means there was some shift from the origin. That doesn't matter though in terms of opening up, down, left, or right. So in number 3, notice that the y is squared. If the y is squared, you know it's either going to open left or right. Take a look at this value out here. Positive is how you know the graph is opening to the right. Finally, in number 4, note that the x's being squared is how you know it's going to open up or down. Taking a look at the other side, the negative is how you know that this parabola is ultimately going to face down. So those are the very first questions you should ask yourself. Which way is it pointing? And then you obviously have to be able to get a little bit more specific. So for the rest of the examples, of which there are quite a few, you are going to graph by finding the vertex, the focus, the directrix, and then sketching the resulting picture. And again, we're going to sketch it in a relatively straightforward way, so you don't have to worry too much about the width. We are going to be using these simpler equations for the moment because the next couple of examples all have their vertex at the origin. And as a reminder, the P, okay, which is what we're going to start by solving for, is the distance from the focus to the vertex and also the distance from the vertex to the directrix. So take a look here at number 5, and then take a look at these equations down at the bottom right hand of the screen. You're basically trying to take problem 5 and make sure that it looks like one of those two equations. So it looks kind of like the first one, except we don't want there to be anything other than a 1 in front of the x squared. So because we don't want there to be anything other than a 1 in front of the x squared, we're going to go ahead and divide by 4. That's going to tell me that 1/4 y is equal to x squared. And it turns out that that is the format for which I want this equation to be in. Again, before I think about graphing, let's consider whether this parabola is going to face up, down, left, or right. So notice that there's an x squared. That means it's going to face up or down. The fact that in front of the y is a positive is how I know that this graph is going to face up. How do I actually go ahead and find those values? Well, the first thing you want to realize is that v for vertex is going to be 0, 0 because of the fact that there are no h's and there are no k's. If there were, you'd have to use the more complicated equation. Then you have to find the focus, which is a point, and then you have to find the directrix, which is a line. In order to do that, you need to find P. How do you find P? Well, because this is an x squared equation, look at this equation here. Whatever is in front of the y, that is equal to 4p. So you're going to take 4p and set it equal to whatever is in front of the y, which in this case is 1/4. Then you're going to divide by 4, which means you are going to get a p-value of 1/16. So let's think about what this graph is going to look like, okay? We know that there is a vertex point at 0, 0. We know that the graph has to face up. The focus has to be in the same direction that the graph is facing, which means the focus is going to be 1/16 units above the vertex in the positive y direction, which means the focus is going to be at the point 0, 1/16. So again, I don't know, you don't really need to have a scale here. It's a little hard for me to draw the dots. So there's my vertex. Here's my focus. I don't know why it keeps doing that. 2 points, vertex and the focus. And then the directrix has to be the same distance from the vertex. The directrix has to be the same distance away from the vertex as it is to the focus. So you're going to go p units in the opposite direction. And again, it has to be a line. So if it's a horizontal line, it's going to be 1/16 units down, which is y equals negative 1/16. And that means that your focus is here, your vertex is here, and you're going to have a parabola that faces up. The truth is, a lot of these graphs are going to wind up looking fairly similar because of the fact that you're not really accounting for the width, but that's perfectly fine so long as you have the correct values for the vertex, the focus, and the directrix. So let's go ahead and take a look at example 6 here. So y squared equals 6x. Again, notice that we are staying with these easier formulas because there is no h, there is no k, which means the vertex must be 0, 0. Looking at this equation, we're going to be using the second one, which is the y squared. So since we already have a 1y squared, we're good to go. The fact that it's a y squared means it's going to face left or right. The fact that it's a positive 6x is how I know that the graph is going to face to the right. Once I know that the vertex is 0, 0, I need to solve for p. So to solve for p, you're going to use the fact that 4p equals whatever is in front of the variable that's not squared, which in this case is 6. Divide by 4. Turns out that p is 1.5. So to find the focus And to find the directrix, again, the focus is always a point. The directrix is always a line. So 0, 0 is the vertex. We know that this graph is opening to the right. The focus has to be p units to the right of the vertex, which means it's going to be at 1.5, comma 0. And then the directrix has to be 1.5 units to the left. That means you're going to wind up with a vertical line, which would be x equals negative 1.5. If you think you are understanding, then maybe pause and try it. This is our last one. That's going to be the simpler version with a vertex at 0, 0. Notice that if I were to look at these versions of the equation, it's not quite in the formation that I would like. So the first thing I'm going to do is I'm going to subtract that 8x. You can't answer any questions about which direction it's going to face until you have it in the proper format. So once I rewrite it as y squared equals negative 8x, the fact that it's a negative y squared is how I know that this parabola is going to face left. Again, no h and no k indicates that the vertex is going to be 0, 0. You're going to solve for p by setting 4p equal to negative 8. That is going to give you a p-value of negative 2. You need the focus, which is a point. You need the directrix, which is a line. So again, 0, 0 is your vertex. Your focus has to be in front of the vertex facing the appropriate direction. So because it has to be to the left of the vertex, that's how you know that it's going to be at negative 2, comma 0. And then the directrix has to be 2 units to the right of the vertex, which means it has to be a vertical line at x equals 2. And then that means that your graph is going to look like this. Again, the whole reason why the parabola works is the fact that this focus is exactly the same distance from the vertex as this dotted line, the directrix. And again, in case you haven't noticed, you should be drawing the directrix as a dotted line. So in the next couple of examples, these are harder versions. So I've used the more complicated versions of the formula because of the fact that there is an h and a k. So the first thing I'm going to answer here is what is the vertex? And remember, the vertex is always xy, and you always do the opposite. So if you look at this x minus 5, that's how you know that your h is going to be 5. If you look at this y minus 3 squared, you know that your k is going to be 3. So your vertex is now 5, comma 3. Looking at the format of this problem, it's written in the way that I want. The fact that it's a positive, the fact that it's a y squared, and then the fact that the 8 is positive, that's how I know that this graph is going to face to the right. Just like the previous examples, my first order of business is solving for p. So I'm going to set 4p equal to 8. That means that p is going to be equal to 2. I need the focus. I need the directrix. So the vertex of this graph is at 5, comma 3. There's the vertex. The focus has to be in front of the vertex, p units away in the appropriate direction. So that means that the focus has to be 3 units to the right of the vertex, which means, 2 units to the right of the vertex, which means it's going to be at the point 7, 3. And then the directrix has to be 2 units to the left of the vertex, which means it's going to be at x equals 3. And then, of course, somehow I lost my focus. And then the graph has to look like this. Sorry that the graphs aren't the best, but for some reason the computer doesn't like it when I try to just draw a single dot there. Okay, here in number 9, again, take a look at the formation. Notice on each slide, I'm kind of giving you fewer and fewer hints to kind of ensure that you're recognizing the pattern. And again, there's quite a few formulas that we've gone through already today. So as always, be adding those to your running list so you have one-stop shopping, easy to refer to. So here in number 9, the format looks good. I noticed that when it comes to the vertex, I'm always going to do HK, which means opposite X, opposite Y. So negative 3 is going to be my H, and then positive 1 is going to be my K. Note that this is a X squared with a negative over here. That's how I know that the graph is going to face down. First order of business is to solve for P. So 4P equals negative 20. that means that P is equal to -5. If you want to go ahead and start going to graph town, so -3, 1, that is, of course, my vertex. Because the fact that the graph has to face down, that's how you know that the focus is going to be P units below the vertex. So -3, 1, you are going to go 5 units down. That is how you're going to get a focus of -3, -4. Again, my points kind of keep disappearing here. And then your directrix, which again has to be a line. Anytime you have a parabola facing up or down, it's going to be a y equals. Anytime you have a parabola facing left or right, it's going to be an x equals, in case you haven't caught on to that already. And again, the directrix has to be exactly P units above the vertex. So since the vertex is at -3, 1, the directrix has to be 5 units above that, which is going to be y equals 6. And again, -3, 1 is where the vertex should be, which means that, sorry about that, your graph should look approximately like this. Okay, and hopefully your graph should obviously be a little bit nicer than mine since you're not having these weird stylus issues. Okay, before we get to the last couple of problems here, we have to do a quick reminder on completing the square. So as I mentioned earlier, you have to ensure that each of these problems is in the proper format. And it turns out that a lot of the time we're going to need to use completing the square in order to do so. As a reminder, if you had a trinomial x squared plus bx plus c, or if you're trying to make a trinomial, you're going to take half of b, and then you're going to square it to find c. This only works if in front of the x squared is a positive 1. So take a look at these two examples. X squared minus 3 equals -10x. In order to complete the square, you have to put all the x's on one side, positive x squared first, and then the regular x term next. Put the constant on the other side. If you are trying to actually complete the square, what you're trying to figure out is what goes on each side, because of course, whatever you do to one side, you must do to the other. The way that you figure out what that value is you take half of the b term, which in this case is 5. Then you square it, which is 25, and you have to add that value to both sides. And then remember, the point of completing the square is you now are able to take that trinomial and write it as something squared. That's the whole point if you want to try to use the parabola formulas. Notice that the example on the right here is very similar. Instead of having positive 10 as your b, you have -10 as your b. Half of -10 is -5, which when you square it, you still get a positive. But notice that when you write it as a quantity squared, it's x minus 5. So whatever the sign of the b is has to be the same as in your final parentheses. So hopefully that is a good reminder. And if not, then just go ahead and Google completing the square. And I'm sure there are tons of formulas. Take a look here at number 10. So this is kind of looking like that general equation that I showed you on the second slide. There will come a time where you'd be able to look at this and just say automatically, oh, it's a parabola, as opposed to being a hyperbola or a circle or whatever. For now, because we're in the parabola section, obviously we know what it is we want it to look like. So if we want this to look something like a parabola, we're going to start by putting all the y's on one side because of the fact that the y is squared. Whichever variable is squared, that's the one that you have to complete the square for. So I'm going to leave the y squared plus 6y over here on the left-hand side. I'm going to leave a little space. I'm going to move the 12x over. I'm going to move the 15 over. And that sets me up for exactly what I want to do here. In order to be able to somehow write something squared, I'm going to have to complete the square. So to complete the square, I'm going to look at whatever's in front of the linear term, which is 6. I'm going to take half of 6, which is 3. I'm going to square it, which is 9. Whatever I add to one side, I must, of course, add it to the other side. The whole point of completing the square is I now want to write it as something squared. It's always whatever the variable is. It's always a squared, and then it's always whatever half of the b term was, including the correct sign, which in this case is y plus 3 squared. Over on the right-hand side, I get -12x plus 24. This is actually still not a perfect version in terms of what I want. So what I actually want to do next is I want to factor out a -12. So that is going to give me y plus 3 squared equals, factor out the negative 12. If you factor out a negative 12 from a negative 12x, that's an x, and then minus 2. So that's the dream. That's the perfect format of a parabola. And now I'm going to finish it up the same way I did the earlier examples. First order of business, the y is squared. In front of the other side is a negative. That's how I know that this is going to be a parabola that faces left. The vertex is always first the x, which gives you the h, and then the y, which gives you the k. That's going to be positive 2, negative 3. 4p is equal to negative 12, which means that p is equal to negative 3. When I go to graph this, so 2, negative 3 is going to be my vertex. Then the focus, which is always a point, the directrix, which is always a line. Remember that the focus always has to be in front of the vertex in the appropriate direction. So that means that it has to be 3 units to the left of the vertex, which means it has to be at negative 1, negative 3. The directrix is a vertical line, 3 units to the right of the vertex, which is how it winds up being at x equals 5. The directrix, dotted line, negative 1, negative 3, that's the focus. And then the graph should look like this. And again, eventually we can get more and more specific by finding x-intercepts, y-intercepts, all that stuff. But for now, I'm really just asking you to give it a sketch. 2 more for you here. And again, if you're feeling confident, you could maybe try it. But the next 2 are really kind of all about the algebra. So if you take a look here at number 11. I don't know, it looks kind of weird. That fraction out front is really just not sitting right with me. So the very first thing I'm going to do here is I'm going to multiply everything by negative 6. That's going to give me a negative 6y, and then it's actually going to cancel the negative 1/6 on the right-hand side, which is going to give me x squared plus 4x minus 2. In this case, because it's the x variable that is squared, that's how I know that there's where I'm going to be completing the square. So I am going to leave the negative 6y on the left side. I'm going to add the 2 over. Then I'm going to leave a little space and leave a space on the right. Now I'm going to complete the square by taking half of 4, which is 2. Squared is 4. And then, of course, whatever you do to the right side, don't forget to do it to the left side. Over on the left side, that's going to give me negative 6y plus 6. Over on the right side, x plus 2 squared. Make sure you have the appropriate signage. How do I make this look perfect? Well, I'm going to take the left-hand side, and I'm going to factor out a negative 6. Just like always, when in doubt, take the negative out. You're not allowed to use the rules unless it's a positive y. So I'm going to go ahead and factor out a negative 6. That's going to give me a y minus 1. And then that's equal to x plus 2 squared. Vertex, hk, so negative 2, 1. 4p equal to negative 6. That means that p is equal to negative 1.5. I need the focus, which is a point. I need the directrix, which is a line. Because the x squared is positive, but there's a negative on the other side, that's how I know that this is a parabola that's facing down. If I want to go ahead and get specific here, so the vertex is at negative 2, 1. The focus has to be in front of the vertex in the appropriate direction. So I have to go 1.5 units below the vertex, which is going to be negative 2, negative 0.5. So negative 2, negative 0.5. Then the directrix has to be 1.5 units above the vertex because of the fact that it is facing down. That's how I know that it's a horizontal line. Y equals 1.5 plus 1 is 2.5. And that's how I know that my graph ultimately looks like this. And again, sorry that my points are a little wonky. And you can get more and more precise with your graphs as you choose.